Good morning. Welcome to Nfpa 70E training. My name is Mike Murphy. I'm a certified electrical safety compliance professional. I have 32 years as a master electrician, and we're going to be talking about electrical safety today. So when it comes to safety, OSHA has always been the what. OSHA tells us what we're supposed to do. But we have Nfpa 70E, which is the how, the shall, how we create an electrically safe working environment. So what are the benefits of following an Nfpa 70E program? We establish our electrically safe working conditions, plan and anticipate our safe work practices, we identify and reduce risks, we're training our qualified employees in things such as proper tools and clothing to wear, establish our safety programs including lockout tagout. So when it comes to electrical safety, we basically have three books that we're looking at. Nfpa 70, that's the National Electric Code. Nfpa 70E, which is all about creating that electrically safe working condition. And we also have Nfpa 70B, which just became a standard as of 2023. So once it becomes a standard, it means that OSHA can now cite it as far as using it to enforce things. So this one is actually very important, and to me, I believe that Nfpa 70B is going to start to make things much safer in our industry. 70B is all about maintenance of equipment. We now have to have a maintenance program with a person in charge of that. It needs to be written down and documented so that we know when we're interacting with equipment, is that equipment actually safe? You look at an arc flash label and the incident energy is labeled on there. There are a lot of factors that go into that, and if that equipment is not properly maintained, that arc flash label may no longer be correct. You may have a different available fault current. You may have a different breaker opening time. You know, when it comes to arc flash, there are two basic things that will save you. Distance, the further away you are, the safer you are, and then time. An arc flash is going to continue to grow as long as that energy source is there to feed it. So when is that breaker going to trip? When is that overcurrent protective device going to open? And if they're not properly maintained, it may not open in the time frame that the arc flash label believes it's going to. So Nfpa 70B is a big step forward in creating some more safe work practices for us. So Nfpa 70E comes out on a 3-year basis, much like the National Electric Code that my electricians are all very familiar with. This is the 2024 version. So when it comes to electricity, we have three main hazards. We have shock. Shock means you came in contact with electricity. We have arc flash, which is anytime electricity takes an unintended pathway, it jumps from phase to phase or phase to ground through the air, it breaks down the ionization in the air, causes that plasma ball, that arc flash, that explosion. And then you have arc blast, which is just all of that, the concussive effort of that arc flash. It's the rapid expansion of the air. So when it comes to shock, these are just some numbers for you here. MA is milliamp, which is 1/1000th of an amp. So at 1 to 3 milliamps, that's where most people start to feel it. 3 to 9, it becomes painful. At 4 milliamps, that's when a GFI will actually trip. GFIs are created to protect people. Breakers, you know, in a panel, a 20 amp breaker, it's made to protect equipment and wiring. It's not necessarily made to protect you, but a GFI is. GFIs are made to protect people. So that's why it has such a low threshold for tripping. At 9 to 25 milliamps, you can get that can't let go threshold, meaning that you've touched electricity, your muscles have contracted, and you no longer have the ability to release your hand, and you are now stuck until that electricity is turned off or somebody has help to release you in contact release, which we also will be going over today. Once you get up to 60 milliamps, that's ventricular fibrillation. That's when it becomes possibly fatal. But you see there, we haven't even reached an amp yet, and we're already at a spot where it could be fatal. And then at 4 amps, if you're not released from that circuit, chances are it's going to be fatal. So it takes very little amperage to kill you, very, very small amounts. Severity of that shock is going to depend on the pathway. So hand to hand, hand to opposite leg, anytime it crosses your chest. A lot of times we actually see through the brain. I'm working on a panel, or I'm working in a box, got my head leaning against a piece of ductwork, and I'm just trying to get that last wire nut on. I touch something hot, and it grounds out through the brain. So the severity is going to depend on the pathway, how much amperage is actually there, what are you actually attached to, and how long. Those are the 3 main factors that go into whether or not you're going to survive a shock event. Just a fun fact, the term electrocution was coined in 1889 before we started using the electric chair on prisoners. Electrocution means that you're dead. It is the result of a shock event. You hear it used incorrectly all the time. You'll see on the news, 2 electricians were electrocuted today on a job site. They're recovering in the hospital. Electrocution means that you're dead, and it should be used in the correct terms. So arc flash, just some statistics for you here. Again, that's when electricity takes that unintended pathway. It's not following the wire, it's not following the bus. It jumps from phase to phase, or phase to ground, and it creates that arc flash. Arc flash can reach 35,000 degrees. That is roughly 4 times hotter than the surface of the sun. All materials at that temperature will vaporize, even a diamond. You put a diamond on a bus bar, arc flash happens, you're going to have diamond bits vaporized and shot at you. Your skin will ignite at about 480 degrees. So we're talking about very, very high, dangerous temperatures. There are about 5 to 10 arc flash incidents a day. That's about 30,000 a year. And just remember, those are the ones that are reported. So think of how many don't get reported. When we get away with something, nobody got hurt, the equipment didn't get blown up. All right, let's kind of pat yourself off and say, okay, we're all good, and we don't report those incidents. Who in the room has a pair of Kleins side cutters where you cut into a couple of wires and had a little explosion, and now your side cutters actually have a little hole where they can be used as a stripper, right? I know, I have them. Yeah, see, all electricians have done that at some point. Well, that's an arc flash. It's a small one, but it's an arc flash. We have from there all the way up to, greater giant arc flashes. So on average, you have about 7,000 burns, 2,000 overnight hospitalization, and 400 deaths a year due to arc flash. About 80% of those, you're not dying on site, you're lingering on, you're dying from the burns later on. You get 2nd and 3rd degree burns over your body. Basically, these are now open wounds. You go to the hospital. Hospitals are very, very dirty. They're filled with infectious diseases. You get infections, you're having surgeries, things of that nature. It's very, very unpleasant and not something that anybody ever wants to go through or have to have a worker or a friend go through. The arc blast, again, this is the concussive effort. There's a lot of talk about how large is this concussive effort. Some people don't believe in it at all. Some people believe that it can be very, very damaging. But the idea there is that there does have that effort. There is a concussive effort that goes with this. It may knock you to the ground. There have been reports of people having eardrums broken, things of that nature. Obviously, if you're dealing with an open area, it's going to be less, but if you have a closed door, it can have a more concussive effort because it can build up and then explode. So it's definitely something that we need to talk about and need to be concerned about. So NIOSH did a study of 224 deaths due to electrocution and 250 deaths due to arc flash. Trying to figure out what exactly is it that went wrong that caused these fatalities. And what they found was that 19% of the time it was equipment failure. That's a pretty low number, right? 19% of the time. That leaves 81% of the time where something else went wrong. And what they're actually finding was not following codes and standards, inadequate training of employees and supervisors, no safe work procedures done whatsoever, no pre-task work plan, no job hazard analysis, things of that nature. PPE, not worn, not provided, or worn incorrectly. And then lockout, tagout, either not used at all or not used properly, or possibly not verifying zero energy. So we go through the whole lockout, tagout process, and then we don't actually verify that the energy source is turned off. That's the most skipped step, is actually verifying that there is zero energy there. Probably the most important step, and we tend to skip that one the most. And all of those things have one thing in common: human error. 81% of the time when it comes to electrocution or arc flash, it's something that we did wrong in the field that led to that. Now it's actually, it's hard to say this, but it's kind of a good thing, right? Because human error we can fix. We can do all of our tilt testing, insulation resistance, megging, all of those things on the equipment. And sometimes you just can't see what's going to go wrong with equipment. But training, proper use of PPE, lockout, tagout, a pre-task work plan, all the human error factor, we can greatly reduce the number of incidents simply by getting better at our job and taking it more seriously. A lot of this is we know how to do it, but we say things like, you know, I've done this a million times. Well, 1,000,001 could possibly be the time where something goes drastically wrong for you. Here's a perfect example of human error. This is a 35,000 to 480 volt transformer. So when they turned this on, they heard a rattling noise. They open it up, and there you have a metal ruler that was left inside the piece of equipment. I mean, it is sitting up there. These are the insulators. I mean, just enough of a vibration, and that's going to fall across the phases. It's probably close enough to have a 3-phase arc flash there. Could be a very, very devastating thing. And that's why we have Annex Q. So the back of Nfpa 70E, which we'll turn to later, talks about human performance. How do we perform as human beings, and how does it affect safety in the workplace? A lot of great information inside of Annex Q. One of the biggest things that we do is we like to build everything so that it looks exactly like the piece of equipment next to it. So imagine I tell you, go to aisle 13, PDU 12, it's off, go ahead and open it up, and you go to aisle 12, PDU 13, or whatever the opposite is. You know, when we're working long hours, we're working in these data centers, a lot of people are working 7 days a week, 12 hours a day. We get tired, we lose focus. That's when people start to get injured. That's when fatalities start to happen. There are reports that as soon as you hit 60 hours in a week, that's when we start to really see incidents popping up. We need to really be focused when we're getting tired. So some human performance tools that we're looking for from Nfpa 70E talk about enhancing our pre-task plan, making sure that we're planning these things out thoroughly before we ever even start. Peer and self-check. I like to call that the culture of care. Caring about the people around you, making sure that your neighbor, your coworker, the person next to you is actually doing things safely. Keep an eye on those people. Keep an eye on each other. Care about each other. Hey, is that the safest way to do that? You see somebody doing something, maybe they're not as qualified as you. Maybe they don't know. Maybe they're walking into a situation where they could get hurt because they don't know any better. So we want to take care of people around us and hope that those people are going to work to take care of us as well. Effective three-way communication. This could be on the radios. You know, we're going back and forth. Or it could simply be making sure that the person you're directing, telling someone to do something, that they're hearing it correctly. Tom, I need you to go turn off breaker B. And then Tom repeats back to me, Mike, you said breaker B? Yes, breaker B, bravo. So that you don't hear breaker D or breaker Z. Construction sites are very loud, there's a lot going on. We want to make sure that that three-way communication is happening so we know exactly what it is we're doing. Questioning attitude. Everybody who works here gets a stop work card. You can stop work at any time and say, whoa, can we hold on a second? I have a question. Or are we sure this is the correct way to do this or the safest way? Are we forgetting anything? Always, always ask questions, always. Stop when you're unsure or uneasy. My dad always had a saying when I was a kid. He would always say, this right here is smarter than this right here. Pay attention. You get that gut feeling, and you're like, you know, something feels off. A lot of times your body, especially around electricity, your body will pick up signals when there's an electrical current around that maybe your brain hasn't processed it yet. You know, you get close to something and the hairs on your arm start to stand up. You start to feel that little static. A lot of times you can feel that before your brain says, whoa, wait a second, is that still on? So pay attention to your gut feeling. Could also be just, you know, you're not feeling right today. You're not in the right frame of mind. So maybe that's the day that you say, hey, look, not feeling it today. It's not a good day for me to work on something that is possibly energized, or we want to make sure that we're always ready to work. We talk about being impaired, and we think of the word impaired, we think of drugs and alcohol. Don't work if you're impaired. Impaired also means you're tired, you're overworked, you're not feeling well, you're sick. Things of that are all different types of impairment that we want to make sure that we're not impaired on any level when we're dealing with very, very dangerous things. And then training. Training is definitely key. And I don't say that just because I'm a trainer. But training is definitely key. The more that we learn, the better off we can be, the safer we can be. And the last one is seeking feedback. So there's an old saying that nobody wants to admit that they have an ugly baby, right? Everybody's baby is the most beautiful baby in the world. Well, there's ugly babies out there. Somebody's having those ugly babies. But when we think about it in terms of us and electrical work, your plan, your step-by-step, your method of procedure, your pre-task work plan, you might look at it and say, okay, that baby's beautiful. I got everything ready to go, I'm good. But you hand it to somebody else and they take a look at it and say, well, what about this, this, and this? You know, did you miss this? Getting feedback from other people, another set of eyes can see something that maybe you're not seeing. When we do a method of procedure, we're going to shut down a panel. We always do a dry run where everybody on the team, we all walk through that process step by step, making sure, okay, everything's here. And I can't tell you how many times we've gotten to a spot where we get to the, okay, we're putting in a new breaker. Hey, that was a special order breaker. Do we know where it is? Oh, it came in, but, oh, well, Tony had it. Well, Tony gave it to Steve. Well, I put it on the shelf. At least now, because we're doing it beforehand, we have the opportunity to find it so that we don't wait until the day that we're doing the shutdown. The equipment's shut down, trying to get everything back on, the customer's there. Now we're cutting corners because, oh, we don't want to look bad in front of the customer. That's why we do all that planning, that training, that feedback, making sure that, oh, yeah, okay, we need to find that breaker. Oh, look, conduit's not finished. Things of that nature. We always want to make sure we're getting feedback so that we can see anywhere we might be lacking. So the day we go to do that work, we're 100% ready and we can knock it out safely. This is the American Electrician's Handbook. This is actually from 1946, and it talks about how we used to test for voltage. Well, the first one is we used to do the tasting method. So you take the wires and you stick them right on your tongue, and it says you would get a burning sensation and a salty taste that would never be forgotten. We've come a long way, right? Yeah, thankfully we don't do that anymore. But when the voltage got a little higher, we would go to the finger method, and that was this. Make a little C, you touch it, and I can tell you, I'm 54 years old. I get into the trade in 1991. This is the way the old timers were checking for voltage at that point. Hey Murph, I need you to put this outlet in. Let me check. Yeah, you're good. There's no power there. They were absolutely doing that. But the reason why I bring any of this up is this last statement. Some men could handle the shock while others could not. Now, obviously, at the time, this was probably 100% male-dominated field. So don't worry about the word men, but just people. Some people could handle the shock while others could not. It was that attack on you personally. Oh, are you scared? What's the matter? You're afraid? You're afraid of electricity? Why are you an electrician if you're afraid of electricity? It's that culture of working unsafely was the way to do things. It's almost as if you're not as much of a professional if you want to stop and make sure that you do things safely. When I was coming up in the trade, we were basically bullied into doing things unsafe. If you weren't willing to stand on top of the ladder and reach, you weren't working hard enough. If you weren't willing to work on it energized, you shouldn't be an electrician. And that's a horrible way to do things. We need to get past this old culture of working safely somehow makes you less of a professional, because it doesn't. It means that you've evolved. You're smarter than I was. You know more than I do, or I did when I came into the trade. We have a whole different culture, but we need to make sure that we're continually pushing that culture. This here, a remote operated safety switch, right? This switch here will operate a breaker remotely so that you can stand away from it, out of the arc flash zone. You hit the breaker, boom, breaker works. If anything goes wrong, you're not standing right in front of it. Now you see he's still wearing a shield and shock-proof gloves. In this scenario, you are still attached by a cord, so we want to make sure that you're still protecting ourselves from shock. But we call this a remote operated safety switch, right? Has anybody ever seen one of these before? You have? All right, don't spoil it. Don't spoil it. Do we call it a remote operated safety switch? No, we don't. I made that up. What we call it is a chicken switch. Why is it called a chicken switch? Because you're too chicken to stand there and flip the breaker yourself. This is not old technology. This is fairly new technology. So that mentality still exists, that somehow, oh, you're chicken, you don't want to flip the breaker, you're afraid. And we constantly have to keep fighting that. If we called it that in the field, I could say, oh, okay, that's kind of cute, it's kind of funny. But for the company to name it that, and they play into that. They play into oh, it's a chicken switch. And it's just horrible. It's not professional. It's not the way we should be reacting to each other. We should be saying, hey, let's do this as safe as possible. And we need to keep fighting that mentality. So to be a qualified person, basically Nfpa 70E, OSHA, they talk about a qualified person as you need to be able to identify hazards, find a way to mitigate those hazards using the hierarchy of controls. And we also want to make sure that we're protecting unqualified people. But they give the companies, Nfpa 70E, OSHA, they do not tell you that you're qualified. The companies themselves need to decide who is qualified. So here at Rosedin, we have our own specific guidelines. You have this specific Nfpa 70E training with me. You're going to be certified in CPR, first aid, and AED. We're going to talk about emergency response training. What do we do when everything goes to heck, for lack of a better word? What is our emergency response plan? 911 is not a great emergency response plan. We want to be prepared for that so that we can get you to 911, but we want to have a plan before that. Contact release. What do we do when someone's got that can't let go threshold? They're hung up. How do we release that person? Battery safety, anytime we're interacting with batteries. Batteries are, as soon as they show up, they're immediately energized work. You can't turn a battery off, so they are very dangerous. Lockout tagout, which could include job-specific lockout tagout, depending on the customer. And then you will be approved by an area superintendent. So you have to have all of those factors in to even be considered to be a qualified person here at Rosedale Electric. And then I always like to say that Rosedale Electric, our qualified people are subject matter experts. A lot of times general contractors, they will have people that work for them that have a degree in electrical engineering. I have 32 years in the trade. That's roughly 64,000 hours. I can tell you it's a lot more than that because I worked a lot of overtime when I was younger. So I have 70,000 hours, let's just throw that out, of working in the field. That's what makes you a subject matter expert. All of that time in the field working. You people here, everyone here is journeyman level. You all have at least 10,000 hours of working in the field. That makes you an expert. Rely on that, use that, push that. All right, so we'll talk about the hierarchy of controls. You see here this pyramid. So Nfpa 70E says that hazard elimination shall be the #1 priority of your safety program. For us, that means turning it off. That is the first thing we want to do, eliminate the hazard. That is the only way to make sure that nobody has any injuries or issues, turning it off. If you can't turn it off, then we go to substitution. This could be substituting that task for something else. A lot of times for us, we deal with medium voltage. We're not a company that does a lot of it. We will substitute another company. We'll hire a company that's more adept with dealing with medium voltage. We sub it out to them. Next one is engineering. Chicken switch. That's an engineering control, something that is built or designed to help keep us safer than interacting with the equipment ourselves. Awareness, that's our arc flash labels, things of that nature, barricades, all those kind of things put up an awareness for people. Hey, something's going on, pay attention. Here's just a quick photo of an arc flash label. We're going to get into these more and talk about them a little bit more. Arc flash labels are required on anything that's other than in a dwelling unit that may have to be worked on while it's energized. I put this up there because all of our temporary services have to have arc flash labels on it, just so that we're aware we're dealing with temporary power. We tend to treat temporary power differently than normal power, but it's not. National Electric Code says the only difference is it's temporary and not permanent. Everything else needs to be done to code, and it needs to have arc flash labels on it. Next one is administrative. That's all of our policies and procedures, our safety program, our lockout, tagout, all things of that nature. Here you see our electrical safety program, our electrically safe working conditions, our energized electrical work permits, our lockout, tagout, our job planning and briefing. So before every job, we do this. We do our job plan, our job brief. Everybody who's involved has a say, whether you're a master electrician or a first day apprentice on the job. Everybody has an equal say to ask, hey, is this the safest way to do this? Can I ask a question? Everybody gets a say in these. And then the last one is PPE. PPE is the least effective method of protecting ourselves. PPE should only be used in conjunction with one of these other parts of the hierarchy of controls. We should never rely on PPE by itself to protect us.